This is GP 1.3, projectile motion number 5. A lot of you had a hard time solving this. It's the one about the tire iron on the moon. So astronauts on the moon hit a golf ball 180 meters, whereas if they did the same thing on Earth, they would hit it only 35 meters. And they want you to find the acceleration due to gravity on the moon. This is one of those problems that can be solved better by using variables rather than anything else. So to start this problem, I'm going to make my typical list of variables. And I'm not interested really in the final velocities here, so I'm not going to worry about them. And I know that they have the same velocity and angle, but I don't know what they are. So that means VIY, I can say, okay, well this is just going to be V sine theta, because that's the vertical component, and VIX is going to be V cosine theta, because that's the horizontal component. And I know, because the problem goes up and then comes down, that delta y equals 0. And what I'm looking for is an equation that relates the change in position to the vertical acceleration, because really that's what the question asked me to solve. It had some changes in position and it said, well, what's the acceleration? So I'm going to give those some variables and then start writing my equations. My equations are basically the projectile motion equations. And in the vertical direction, I know this is 0, and then I'm going to say V sine theta t equals plus g over 2 t squared. And I can solve this and get rid of one of the t's, and that is going to give me one of the useful equations that I need. In the horizontal direction, I have V cosine theta t, and I'm going to solve that for t. So delta x equals V cosine theta. Delta x over V cosine theta equals t. Then I add in my equation from the other page, and I'm going to take this t and sub it in over there. So that means I get V sine theta equals minus g over 2 times delta x over V cosine theta. And I know that the V sine theta and the V cosine theta are basically the same, and I basically have proven that g and delta x are inversely proportional to each other. If I rearrange this equation, I'm going to get V squared sine theta cosine theta 2, maybe even a negative sign, equals g delta x. And this bit right here is going to be the same for both the moon and the Earth. So that means that g delta x on the moon is equal to g delta x on Earth. And once I have that equation, I can just put in my actual numbers. So this is what I'm looking for, and that's going to equal 9.8 times my 35 over 180. So that way I really didn't have to use any other numbers to solve this problem, and the answer is 1.9 meters per second squared.